In this lecture, we'll get familiar with the lone data CSV file we'll be working with throughout the section. Before we jump into Python, let's open it in a simple text editor, like Notepad++, and have a quick glance. We see a dataset that contains both text and numeric data, as well as a header clarifying the contents of each column. Additionally, the first column is called ID. We determine that each row consists of information for the account of a loan candidate's application, and each candidate is described by their ID. Therefore, during this practical example, we'll interchangeably refer to the rows as accounts, candidates, or applications. Examining the data further, we observe that the columns aren't properly aligned, so it's difficult to immediately tell whether there are missing values in the dataset. Despite this, we notice that this CSV uses a semicolon as a delimiter, so we need to keep that in mind when we import the file in a couple of minutes. We can continue trying to examine this ill-formatted dataset here, but a more appropriate course of action is to jump into Python and load it up. We'll start by importing NumPy. Convention dictates we do so as NP. For easier viewing, we'll also call NumPy's setPrintOptions function. We'll use this tool to improve the way we see the outputs on screen. To achieve this, we'll set the suppress argument to true, line width to 100, and precision to 2. These arguments will respectively stop NumPy from using scientific notation to express numbers, extend the number of characters we fit in a single line of output to 100, and only display the first 2 digits after the decimal point. Setting these print options will ensure we don't often see rows of an array displayed over multiple lines, which will allow us to interpret the results more easily. Of course, we can choose to set the line width to 150, 200, or another value. But 100 usually suffices in showcasing all the elements we need to see on the same line. The exact same thing can be said for the precision argument, since 2 elements after the decimal point are more than enough to get a good idea of the numbers on screen. To clarify, specifying these arguments won't alter the numerical values NumPy uses to compute mathematical operations. It'll only affect how we see their values on screen. Then we'll go to a new cell and store the loan data into a variable, which we'll call raw data NP. When we examined the CSV file in Notepad++, we couldn't tell whether it contained missing values. Now that we're using Python's capabilities, let's try the load_txt function, as it will return an error message if the dataset is incomplete. The name of the file is loandata.csv, and it uses a semicolon as a delimiter. As you know, conventions dictate that we display the dataset after importing it, so we can call raw data NP on a new line and run the cell. We get an error message explaining the function failed to convert strings to floats, so we should switch to generate from text. Let's try it out. This time, the cell runs without returning an error. We see an array riddled with NaN values, which could be either text or missing elements. In fact, the entire first row is non-numeric. So we can use skipHeader to omit it. Good practice dictates that we also set AutoStrip to true because it removes excess white spaces, which can distort our columns. Okay. In the next lesson, we'll examine the missing elements of the dataset in more detail. Until then,